Okay, while Travis is getting set up here for our final presentation, one thing I wanted to mention is that NutraDrip is adding agronomy resources. So we have hired one part-time agronomist, and we hopefully within the next week will have a full-time agronomist on our staff. So as we look, one of the things that we've recognized as we've grown is that we need more agronomy resources for our growers to help with those in-season decision-making processes and how to get all that data funneled through. So we are adding additional resources this year in agronomy specifically. So I wanted to mention that before we wrapped up here. So, all right, we'll turn it over to Travis and give him our attention.
Kurt, I will need that. All right, well, thanks for everybody for sticking around here. We'll try to make this quick so we can get back to getting planters ready or whatever you got to do yet today. But I wanted to kind of wrap everything up with, how do we operate our system? We learned a lot today about what you can do with your drip system as far as nutrient management, water management, even effluent management and fertigation with that. So, how we'll get down to the nuts and the bolts of the system. I guess that's what I'm going to go over and explain. So the kind of the operation and maintenance that I'm going to cover. So things to consider to optimize our drip system. We've heard a lot about that today, but kind of on the system level, we'll take a look at that. Understanding your drip system. I think that's the key thing to understand your system to make the most of it. And then kind of what NutraDrip offers for our service package, for our service options. So things to consider for optimization. How many inches of water can I apply? What is my water limiting me, or do I have all the water I can? And if it is limiting me, what can I do about that? Ofer kind of touched on when and how much to water. I think the crop advisor is going to be a key in that, and I'm really excited to start using that more than just for our pilot projects. Automation and taking control of your system. I think probably most of there's guys here that have systems are familiar with automation and have some sort. But we'll take a look at what it can do for you. And then fertilizer injection, I think as Tim mentioned, multiple people, that's a large part of a big advantage of having a drip system. So when we look at water, how much water do I have? So if you have a pond or surface water, you're limited by how much is sitting there, how much Mother Nature, the good Lord, gives and replenishes that supply. Or if a well, how much is my pump outputting? Even if you do have a lake as well, how big is your pump? How much water are you able to pump? And then kind of look at how many gallons do I have per acre. So if I got a 100 gallon a minute pump and I'm only irrigating 20 acres, I'd have 5 gallons a minute per acre. Then the big question is, how much water do I need? Ideally enough to match ET. That's kind of what Ofer talked about with their crop model, finding the ET and then being able to replenish what the crop's using with your irrigation system. So generally that's fallen between 2 to 5 gallons a minute per acre. I have seen it above that, especially this past year when it was so hot and dry down where I was from, down in Missouri. We were in, I think, Kylan Hunt, he's had a presentation as well. He did some research where even on the same year, same plot of ground, different hybrids had different ETs as just with the crop genetics, anywhere from 1700s to 3200s, I think is the range he had given. So if I have between 2 to 5 gallons a minute per acre, converting that to inches, that's 1/10 of an inch to a little over 1/4 of an inch per day. Ideally, we shoot for that 5 gallons a minute per acre because that is going to cover most of your hybrids as far as your ET. We do have systems that are less, and I'll give an example here before long, that are less than that 2 gallons a minute per acre, and you have to get really creative to make that work. Also, another thing to look at is future expansion. With my system, making sure I size my system big enough to handle adding more acres, because that can, if you limit yourself there by your water source, you're going to limit how many acres you can put in. So I guess back to answering that question, the 2 to 5 gallons a minute an acre would be what you would need ideally. All right, so the limited water scenario, I think this particular field has showed up several times today. This is down close to Springfield, Missouri. We started out with, I think it was 220 acres up here as first phase with a 1,000-gallon-a-minute well. So that was really close to that 5 gallons a minute per acre. And we had potential to expand, but the land came up for sale less than a year later. Ended up buying another 500 acres. So out of that 500 acres, we're irrigating another 300 plus or minus 10 acres. So now his gallons a minute per acre is well under 5 gallons a minute. I think it's close to 1.8. So this farmer has gotten very creative with how he can really do more with less. And we're looking at this year. He's looking at planting 2 different corn crops. The first planting we're going to plant as early as he possibly can, and it's going to be a 90-day hybrid. And then as you can see, we got a lot of little zones. This was all fenced. It was pasture ground, so he's still running cattle. So that the later planting of corn that he will plant will be still be in wheat, so that he'll graze off. And then that first planting, once it's harvested, he'll go in with a cover crop and graze that. So it's a rotation of multiple crop stages as well as cover crops and grazing. So he's really able to turn a lot of ground into production just with a little bit of water. So that kind of covers these first 2 options of planting 2 different crops and stage plantings. If we are, again, with limited water, utilizing your soil moisture holding capacity of your soil, you can use your soil as your fuel tank, fill it up with water, and then as the summer gets hot and you can't keep up with ET, you have that reservoir of soil or of water. And then the soil moisture probes that I mentioned down here are very important for that. So you have your fuel gauge so you know where you're at with that water. Back up to the regenerative ag practices of using cover crops to conserve the moisture as a cover to limit evaporation, increasing your soil organic matter. There are all ways you can get more done with limited water. This past year, this has really stuck out to me, longer run times. So on his particular field, we were running, I think, 8-hour sets every day. So every day we were watering the corn, just a little bit of water. And that corn was so thirsty, it was pulling the moisture, but basically as fast as we could put the water on, it was pulling it away. So our wetted bubble of water was very small. So the roots were exploring very little of the soil. So there was a lot of nutrients we weren't having access to because it was so bone dry except for that small circle. So running, for a full day and then skipping a few days and run another full day or whatever, again, it's going to come back to your soil type and how much water you have. I think we'll see a lot of benefit from that. I threw this slide in here. If guys are limited by your well's output, we have software to look at your elevations, looking at putting a reservoir in to hold water, or if you don't have any well at all, being able to store that water. And then back to going to the question, how much water do I have? We could also use this to calculate the amount of volume you are holding, because you definitely don't want to use up all your water by tassel time, and then you have grain field period where you don't have any water. So knowing how much water you have in your reservoirs, it would be key to managing how you spend that water. All right, so understanding your irrigation design, this is key as well to tell you, like I got another slide, it's zoomed up a little closer. When I run my system, what's happening in the field? How much water am I putting on? And where is that water going? So here's one too far. Here's a close-up of that design. It tells you your zone number, your acres in that zone, and the flow per acre, as well as the pressure and the uniformity, which it all should be above 92 or 95. And then, so this is a key number, the 0.02 inches per hour. So if I run that zone for 1 hour, I'm putting on 200ths, or if I run it 10 hours, I'm putting on 2/10ths. So that tells you if you're trying to match ET, if I'm losing 2/10ths a day, I need to be running for 10 plus hours. And in here also, obviously at the well, it's producing 975 gallons a minute or whatever your particular system is sized at. If you don't have this design or don't have good access to it, let us know. We'll certainly print you off a big design so you can see it hanging there by your controller, because it's the roadmap of the system. I wanted to talk a little bit more about automation, kind of tie it together what Ophers was talking about as well. Having automation, I think most of our systems that we've installed have automation, but just some things that we can do with that. Obviously, the biggest thing is one of the big things is remote access, being able to control that from your phone, being able to monitor it. Advanced programming and scheduling, being able to time your watering based on what you're learning from Moisture Pro, based on your crop models, and scheduling that around rain events or your busy schedule, setting a program in and leaving it and letting it do its thing, especially with labor shortage, as hard as it is to find good labor, being able to let the controller do it for you. Also with a precise fertilizer control, being able to put in the amount of fertilizer you need when you need it, and also keeping that as hands-free as possible. Historical data recording, got some more slides on that. Basically recording what you're doing so you can go back and see, how much water was I putting on, how much fertilizer did I put on, especially when it comes to state records that you have to turn in for water management. Remote diagnostics. So if you do have remote access, the team here at NutraDrip can watch your controller, can help you learn it, can help you really do the best you can with that controller. And then if there's any problems with it, we can jump on and see. It may save us a service trip. So subscription costs can look expensive, but if it saves you from us having a bill you for a service trip, subscription cost looks pretty little. So, also alerts, getting a text alerts on your phone. EC and pH monitoring, especially when it comes to effluent control, being able to make sure we aren't putting too high of salts into your soil and actually hurting your roots of your growing crop. Here's just some screenshots of the scheduling and reporting from a particular controller, being able to put multiple programs in if you have multiple crops, having different programs for fertilizer applications, or if you're just watering and how much water, that all can be customized and scheduled and put into a calendar. This next picture I have is just a graph. I think I threw up your flow with the water meter as well as pressure. This is really critical for diagnostics. You can see my flow, when my flow would dip down, just like right here where it dropped down, my pressure went up. So either I probably dropped a few zones, so there's more water pressure there. You can see I shut down, my pressure was low, or my pressure was 0, and the flow was 0 as well. So if there is an issue, this is a good way to tell what is going on. And like Ofer talked, being able to integrate your soil sensor data, even tying in the Go Guru probes, and overlaying that data with this so I can see when my zone turned on and how long it ran for. How did that affect the water in the soil? Where did that water go? Was it too much or too little? I think that's really things you can start seeing as well. Fertilizer control. There's a couple different ways to inject fertilizer by quantity. So we can tell the controller we want X amount of gallons, 100 gallons. It pumps it out. It's done. You can do proportional injection, which is for every 1,000 gallons of water, I want 10 gallons of fertilizer, whatever you want that set at. To always keep especially when you're adding, like if you would do what Cortland was talking about with adding sulfuric acid to your water, you could say for every 10 gallons or 1,000 gallons of water, I want 1 gallon of acid to go in with it to keep a set pH. We can also, with the controller, with fertilizer control, for the blend effluent water and fresh water, like the manure, and keeping that diluted. And that's done by EC control. So that's all automated if you have that set up on your controller. To the automated zone fill up and flush. So before we run fertilizer, we want to fill the zone up with water to pressurize it, run our set amount of fertilizer, and then instead of keeping that fertilizer in the line, run another hour or so of water to clean that out. So a lot of you guys, if you have fertilized and we've helped you set that up, we've done that. It's usually programmed in the backside of the controller. But again, it's all stuff that can be done through automation. The remote control threw up a couple screenshots from my phone, getting text notifications if something's wrong, or even just to let you know what it's doing. Again, the system self-diagnostics. Actually, that would be, if the controller has some steps built in, if it does come up with an alert, it's going to try several things to fix it itself. If it can't, then it starts sending you alerts saying something's wrong. So that's all happening on the back end, and then having the control from your phone to see what is going on, and then your alerts. And even like when we start integrating our probes and weather data into the controller, it'll start alerting you with different thresholds. If the moisture did get so high or so low, hey, you need to address this type of information. So now on to maintenance. Maintenance is key to system longevity. If we keep our system and our drip tape clean, it's going to last for years and years. So we at NutraDrip want to help you guys with your success with that, to be able to make your system last as long as we can. So we offer several different options. Spring startup. I think a lot of you guys have probably got spring contracts. I'll show an example of what we do offer through our spring startup. In-season agronomy support, days like today, where we train guys and really help them understand the most of what they can of their system. Winterization, making sure your system don't freeze, and then the acid flush, I think Cortland alluded to as well. So I'll go into more depth here in the next few slides. So this is just a screenshot of a maintenance estimate. We have the spring startup per acre, the winterization, and then some mobilization in there as well. It's custom to everybody's field, so they should, if they have any questions, I should point out, Joel's not in here anymore, but maybe Kurt mentioned this already. Joel being our service manager, keeping track of all this. He's doing a great job with that. So when we do the spring startup, this is our checklist of things we're fixing or looking at and making sure they're operating. So when we show up, we're making sure the pump's going to work right, your filters are working right, the sand levels in your filters are good, make sure there's no leaks in the filter station, your sensors are working, the controller's doing what it's supposed to do, and valves are functioning as they should in the field. So there's a whole list of stuff we go through. So pretty thorough check. Leaks, I think that's the most talked about thing in drip maintenance is, how many leaks am I going to have in the field, and how am I going to address those, especially when people start worrying about rodents. I'd like to tell guys that as far as rodent leaks, if it's similar to if you had a shed infested with mice, if you parked your combine in there for the winter, you pull it out next spring, you're going to have problems. Those mice are going to destroy the wires just like they would do drip tape. So if you have a field that's already has rodent pressure existing, you're going to have problems. But if you bait those mice, put repellents in your combine, you're really going to have very minimal problems, just like you would in your field. We're using drones with thermal imagery. This was just from Monday, I believe. If you can see that dark purple spot. That's a colder temperature. That's the water leaking. The ground's warmer around it. There's also another small leak right there. You can see it as well. So that's helped us a lot find most of the leaks in the field. And then we can go ahead and create a map, and we can start pinpointing all those leaks to be able to start tracking where most of the leaks are coming from. If we year after year we see leaks on a certain part of the field, we know we have a problem of rodents, or maybe it just is some compaction and rocks or whatever it would be. We can probably start dialing in a little bit on that. So drones have helped us out a lot, and really started seeing some things and helping us out as far as keeping leaks through the middle of the year, keeping them fixed. In-season agronomy support, like Kurt mentioned, we're hiring agronomists to help us with this, help guys understand soil tests, tissue tests, because there's even a lot of things I don't understand, but there's a lot we can learn with that. Helping guys understand moisture probes, like David Salone, they have a lot of instructional and educational videos for us to learn from. So us being able to provide those to you is a lot of it's key for understanding them. We do these agronomy meetings mid-season as well, or late season. Also webinars, blog posts, video posts that we send out. And if you're signed up for our email, you should kind of get updated on that. We also spend a lot of time helping you learn your controller, because they have a lot of power if you can use them. Roy and his team just also helps us out a lot. And if you have questions we don't know, Roy and his team can help us out for sure. All right, winterization. If that's on your contract, to kind of a price set on that, where we bring a big air compressor around, send air through your drip tape to blow any water out. You can see that dirty air water mixture coming out of your pipe. That's just to keep your PVC pipe from freezing and cracking. The drip tape can empty itself out, and it's got enough flex in it. That's usually not a problem of freezing, but it's all the PVC pipe and getting that drained. And also with that air compressor, you're cleaning. It's a lot more aggressive than a water flush. So that's another advantage to that. Acidization. If you have poor water quality, this is going to be really key. Typically, just for your moderate to average water quality, doing an acidization every 24 inches of water applied, which ends up being every 2 to 3 years, that's where we go in and use sulfuric acid, like Cortland talked. Drop the pH of the water to 2, run it through your system, let it set 15, 20 minutes, and then flush it out with clean water. And that'll break down and dissolve any calcium buildup, silt, other gunk that's settled in your drip tape, clean the emitters out. Also would clean up any algae or bacteria growth. So you'll start noticing your system, year after year, if your flows keep dropping off, that's how you know your emitters are starting to plug. So running your acid through at that point would be a good way to clean it up. But obviously verify what that tape and what the emitters look like by digging it up. Just take a shovel out, dig up a chunk of tape, and we can help you analyze it as well. The growers down where I'm at by Springfield, they have really good well water, so I don't anticipate them needing to do an acid flush. It could be 48 inches of water or even more, because of how clean their water is. But when you start adding fertilizers, pond water, having high iron or manganese, that can start plugging up your drip tape and causing more problems. All right, so I'm going to spend a little bit of time as well on filter maintenance and some of the other drip system components, maintaining those and kind of helping you understand a little bit how they work. So if there is a problem, you can maybe dig into them yourself a little bit as well. So if these are the two most common filters we use, sand media and disc filters. I think I got more slides showing them, but like Cortland said, the sand medias are for your dirtier water. They have more filtering capacity. I think this next slide kind of is an animation. If it plays. Played this morning for me. Try it again. Well, we may just skip it. But basically, the sand in this tank, it's mostly full, so running that water through the sand, that's what cleans it, and then it does the reverse of that to clean itself out, to back flush or run water from the bottom back up through it. It lifts that sand and carries the dirt out with it out a separate manifold and dumps it in the ditch. And there's part of our startup process is us checking to make sure that when the filters flush, they aren't flushing the sand out with it. There's a valve we start closing down to limit how much water comes out so it doesn't carry that sand out with it. Okay. Yeah, if you wanted to click it quick. There's your filter sand and then the manifold that the water goes down through. You can see the dirty water coming in, and then it's all automated when it's dirty enough to clean itself out. It triggers a valve to switch up here, and then sending that dirty water out a different port. And then it's back to going again. And you'll always see we have multiple filters together. That's because the other 1 or 2 plus filters are supplying the clean water for these to backflush themselves. I think the next slide has another animation as well of a disc filter, kind of how they work. It's the grand scheme of things, that's a similar process, but it's using discs packed tightly together instead of sand. If it doesn't play, it's fine as well. Okay. Gist of that is those discs are packed tightly together, and then water's flowing through those. And then when it cleans itself, it separates those discs, blows water through it, and then again dumps it out another port. But ultimately, the filters, they're cleaning down about the same mesh. It's just the sand medias can handle a little higher level of silt and dirt in the water. I think the next slide after that, we're looking at how the solenoid, how the controller's electronically telling those valves to open and close through an aquative. That's a little blue solenoid that sits on your valves and the filters. They have an open closed auto position on them. They're gonna go. Okay, sorry, we can just jump to the next slide. There it goes. So you can see the clean water coming in. It's going through those discs. And as soon as they get plugged up enough, you get the pressure differential. This backflush valve switches. Water's flowing backwards through it, separates those discs, blows the dirt particles out, and then just rotates through all those modules. There it goes. So one advantage, or several advantages of these disc filters is it's a smaller footprint, so it's not taking up as big of an area, and also not as much water is needed for the backflush. But you can see it's cycled through all 3 of those, and then pressure's back to the operating pressure. So there we go. All right, to flush your filters, whether it's a sand media or the disc filters, you need 25 to 30 pounds of pressure to properly clean them to get a good solid clean. And you can tell where your pressure at is by this pressure gauge hanging off the top of your filters. The little black knob. It's a 3-way selector. They're one way. We'll show you on the pressure gauge what your pressure is on your top manifold. You turn it another third of a turn, it tells you the pressure on your bottom manifold. And just if you have clean filters under normal operating, you should be around 2 psi difference just from the resistance going through the sand. When you start getting to between 7 and 10 psi difference, that's when the controller signals to backflush and to clean itself out. And again, you need that 25 to 30 psi or more pressure to clean it out. This is that brass valve I was talking about that limits how much water is backflushed. We aren't flushing sand out, but it's also important that it's open far enough that it's getting enough of the dirt out, especially if your well's pumping sand. I think this is an example of a well that was pumping a good amount of really fine sand, and the backflush valve was set down too tight, so it wasn't flushing any sand out, and that sand just built up and filters stopped working, and we couldn't figure out why until we opened them up, and there was just this fine well sand. So when it was flushing, it wasn't flushing enough of that light well sand out. So you can tell the difference between it. It's a really fine, lighter sand, whereas the filter sand's a little bit coarser. Usually you can tell the difference looking at it. This was that slide I was talking about when the videos weren't working. And again, NetFM has a great YouTube channel that explains in depth a little bit more how this works. But these solenoids, the valves that have the open close auto sign on them, in the auto position, they're waiting for a command from the controller to turn them on and off. But if you would go and open them for a filter, you'd say let's turn it to open. See, it's normally closed. So when it opens, it's sending water from the high pressure to the command. So it's sending water from the solenoid to this backflush valve on the filter. And that's what opens and closes it. So if something's not working right, when you turn this to open, you can always pull this spaghetti tube fitting, that black line, pull that off. If it's got water coming out, it's trying to open the valve, but if there's no water there, this solenoid it's not doing its job and giving it that command. Here's that same solenoid on a valve. So on a valve, they're plumbed in opposite. So to keep the valve closed, it's always sending water to the valve to keep water from passing through it. So when this valve opens up, it actually dumps the water off of that valve. So it's in reverse to what the valves on the backflush manifold are doing. But again, you have to turn these solenoids on and off. It's just a 12-volt latch signal. So these zone valves can be operated with a solar panel and a radio. So very low power consumption and work good for fields that are spread out like that one I had showed a few slides back. Here is just the demonstration, kind of a cutout of those emitters in the drip tape. So we've talked a lot about the filters. Each of these emitters have some sort of a filter mechanism built into them. I got a video here next if it plays, kind of an animation again of how these emitters are able to somewhat filter themselves from any debris in the line. So this one I have the example of is the pressure compensated. So for rolling terrain, you kind of see on the animation how it compensates for that pressure differences and still waters an even amount. Are you able to play this video? All right. All right, again, yeah, this is the dripper we use in rolling terrain over hills. This was an actual field we put it in. So this is that filter mechanism I was talking about. In the bottom side of that emitter, it has these small slots. So it's going to keep your bigger particles out of there. And those bigger particles will just stay in the drip line and those will get flushed out eventually. So this is that flow path the water has to come through. As the video says, there's a lot of turbulence in there, so that keeps any particles from stopping and getting wedged in there. Iron and manganese can be something that does build up, and even calcium in your hard water, but that's where we use that acid flush to clean it out. This is the example how the pressure compensated part works. There's that silicone flap in there that limits how much water passes through as the pressure increases. And then it's kind of got a self-flushing mechanism built into it if any debris and dirt does get in there. And also a root barrier. Typically, we don't see roots getting into your drip line and plugging any of the emitters up just in your annual crops of corn and soybeans. We will sometimes see it in alfalfa, especially in limited water environments where you aren't watering enough and those alfalfa roots are looking for looking for more water than what you're giving it. They'll start going down and finding a way into that drip line. And this flap also kind of prevents some of the roots from getting into it. There's a different style of emitter. Typically, we don't have the copper oxide embedded into them, but that is an option if root intrusion is a problem. So, really a lot of technology built into that emitter, so being able to understand a little bit what's going on can help us kind of figure out the best ways to manage the maintenance on it. Right, the last slide I think I have here is tape flushing. So again, that video showed all those bigger particles that don't make it through the emitter that keep passing through or hang out in the drip line. And we typically do a tape flush when we do the spring startup as well, and then the winterization that'll blow it out, and that's typically enough flushing for average to good water quality. But if we have poor water quality, doing another few flushes during the year can help out a lot as well. So we're opening up the valves at the end of the field, and that allows the water to rush through that drip tape, kind of as you've seen in that animation, and then any particles that settled out in there is going to leave the system via the flush valve, as you can see here. So you can, to really get a good flush, increase the pressure on those zones. So each of those zone valves that I showed a few slides back, they are pressure regulating, so they'll limit how much water or how much pressure goes into that zone based on what the design shows. But for flushing, we can increase that by 10 or 15 psi, and that'll really give a better flush, clean, do a better job cleaning that drip tape out. So I think that was the last slide. If there's any questions, feel free to let us know or give us a call mid-season. We're happy to help. So if not, I think that's all we have. We'll let Kurt say the last few words, and appreciate everybody coming.
All right. Thanks, Travis. Thank you to everybody who stuck around here today and joined us in person. Thank you for everybody that joined online. If you have any follow-up questions, definitely reach out to us. Feel free to stick around here. And we look forward to a good season and hopefully a bountiful harvest. So thank you again. My wife has some door prizes, but for the smaller crowd, we have enough for everybody. Or for one per grower, I should say. So see my wife before you leave, and she'll get you a little gift.